This video, I'm going to talk about the minimum cut, maximum flow theory to solve flow problems. Now, what are flow problems? Things like you might have a network that describes a supply chain for a company, and they're thinking about how much product they can move from one place to another. So maybe from the factory to the customer. And they might, use a different system of kind of trains, planes, trucks to do that. And so we can use this theorem to analyze these problems and solve them. For example, here we've got Audi, a car manufacturer making cars in Stuttgart. And then, there's various ways for them to send those units around the world, and the customers are in Los Angeles, so where we can do what are called these cuts that look like these lines here. One thing that is important about these cuts is that they fully separate what we call the source, so where stuff's coming from, and the sink, where it's flowing into. So, with these flow problems, it kind of the language comes from things like plumbing, right? Like the source of the water and then the sink where it is flowing out. For a cut to count in our network, it has to fully separate out the source and the sink and go all the way through our network. So all of these are valid cuts. But for example, if I just did a little cut like this, like that is not okay, because it doesn't separate the source and the sink, so that one wouldn't count. Okay, so with this max flow min cut theorem process, you could think about it as you're drawing in all the different ways to cut the network in two, where the source and the sink are on opposite sides of the cut. Admittedly, in practice, you don't really have to do that. You just have to do all the ones where you think you're going to get this minimum value from the weighted network, where we're counting how much of the weight goes from the source side to the sink side. If it's going the other way, we just ignore it. Because, if you think about stuff flowing, if it flows back towards the source, that isn't going to help you, spread more stuff towards the sink. Okay, once we've found the minimum cut, that tells you what the maximum flow is. That's what our theorem is telling us. So let's do a simple example. You can pause the video and give it a read if you'd like, for a bit of the flavor, so to speak. But yeah, we've got a poutine company moving poutine across Vancouver. And so when I'm doing one of these problems, a lot of the time I just kind of start by doing, let's look here. So here's our cut one, and we're saying, okay, we're just going to add up. So this is I believe this is our source, and this is our sink. So if we think about adding all this up, it'll be 29. Maybe I'll do another one I'm trying to think, okay, how can I minimize this? So actually, this one is only 24, so that's already better. Say I would go just straight down the middle. I've got 14 plus 12 is 26. I don't care about this 9 because it's going from the sink side to the source side. So that's no better than this one at the end. Maybe if I go this way, well, that would be 13 going from the source side. This 4 doesn't count. It's going from the sink side, but this 12 does count, so it would be 25. Yeah, anything better? Probably not really. Maybe we'll try this way. So it'll be 14 plus 20, that's 34, too much. Yeah, so, I might have even worked out just about all the different cuts. There are other ones that perhaps we could do here, but again, we're going to get about 30 there, so that's not going to be any good. So it looks like our minimum cut is 24. So we're saying the maximum flow is 24 units of poutine. So yeah, we're working in tons here apparently. So 24 tons of poutine is the maximum that can flow through this network, go from the source side to the sink side at any one time. Here we've got another example. Feel free to pause the video and give it a watch. Do I have a bigger graph? I don't. Okay, well, yeah, so I made this little network of Hobbiton, and we're going to try and see how many hobbits can go from the source at Bag End to the sink at the Green Dragon. So when we're doing this, perhaps this example is good for showing some things where there are some cuts that you just kind of wouldn't bother doing. If we just look at here, out of Bag End, it's overall 24, that cut, separating the source and the sink. So, if we look here, anything going that's separating this, so say this, right? there's no way that's going to be less than 24 because it's got an edge in it that's 25. So we can immediately go, well, really, I'm not going to bother counting up how much that cut is because it's going to be definitely more than 24. So yeah, we can have a bit of a look around for a few more, like maybe going this way, but that's going to be what, 27 plus 8. Oh, definitely more than 24. So what, that'd be like 35 maybe. How about around here? We've got, so 6 plus 5 is 11, plus 18, 29. Too much. Looking this way, that's definitely going to be like more than 25, right? So unless we can find something nice, I think we're probably going to say, well, our minimum cut is 24, so our maximum flow is 24. And yeah, there's you know, a few more cuts in there. That's possibly even every cut I've put in there. And yeah, 24 is our best one. So actually, our first cut was our min cut, so it's our max flow. That is it for our flow problems. I hope that's helpful for you.